A ball is rolled in a straight line along a surface. So here's the surface. This line represents the surface. The distance s meters the ball travels is given by s equals 18t minus 2t squared. So we have a formula that gives s is distance as a function of time. So s could be positive or negative actually. For some values of t, s will be positive, the ball will be moving to the right. But for other values of t, the ball could be somewhere in the negative s region. So this is the formula. If we want to get the position at the ball at any time, we just plug in for t. So for example, if we want the position of the ball at t equals 0, we just plug 0 in for t. And this gives us 0. So when t equals 0, the ball is here. So this is the ball. So the ball is at 0, s equals 0. Say when t equals 10, we could get s. It's 18 times 10 minus 2 times 10 squared. That's 180 minus 2 times 100, 200. That's minus 20 meters. So when at 10 seconds the ball is somewhere over here. Its position is it's at minus 20 on our s-axis. Okay, anyway, this is just an aside. This is just explaining what the formula actually means. It gives us the position of the ball at any time t. Now in the first question, we're interested in the speed of the ball. Now, before I want to explain what the speed of the ball actually is. The speed, denoted by the letter v, think of velocity, although velocity and speed are not actually identical. But the speed is the magnitude of the velocity. The speed is given by the derivative. We differentiate this function. So we have s as a function of time. So we differentiate s with respect to t. Like if we had y as a function of x, the derivative would be dy dx. We'd be differentiating y as a function of x. The dependent variable here is s and the independent variable is t. So we have to get this derivative. Now, how would you remember to do this? Well, what we have here is ds, which is a distance. S is distance, remember, over dt, which is a time. Distance over time. You might remember that average speed is given by distance traveled divided by time taken. Actually, this is instantaneous speed because the time taken is a tiny differential, dt. So if our ball is here and a very small time interval dt later it's here, the distance traveled will be ds. So this distance will be ds and the time taken will be dt. So we're getting the speed at an instant as seen by a speedometer, say. If you're driving a car, the speed at an instant is got by looking at the speedometer at any particular instant in time. So that's the idea. So that might help you remember. It's distance, which is ds. Well, it's an infinitely small distance actually, ds, over an infinitely small time taken to cover that distance, which would be dt. So we need to calculate the dt for this function, and that's quite easy. It's an easy function to differentiate. The first term is 18t. The derivative of 18t with respect to t is just 18. We just drop the t. Or you can think of it like 1 times 18, t to the power of 0. We subtract 1 from the power. 1 minus 1 is 0. But t, anything to the power of 0 is 1. So t to the power of 0 is 1. So if 18 times 1 is 18. So the derivative of a linear term is just got by writing down the coefficient of that variable, t in this case. If we differentiate minus 2t squared, we get minus 4t. 2 times minus 2 is minus 4, and 2 minus 1 is 1. So this is the speed at any time t. So what time are we interested in this question? The time we're interested in is 3 seconds. So the speed at 3 seconds, we could write it like this. V of t. V is a function of t, but of course we have t is 3 in this case. We want t to be 3. Or we could write it like this, ds dt at t equals 3. That's another way to write it. Yet another way to write it is to use the derivative notation s prime at 3. Okay, we're differentiating s with respect to t, so s prime is used to indicate the derivative. Another way of saying it, ds dt. And we just plug 3 into this. So we have 18 minus 4 times 3, which is 18 minus 12, which is 6. What are the units? Well, speed is distance over time, so it's meters over seconds. The distance in this question is actually in meters, and the time is, distance in s is in meters, and the time is in seconds. So we have 6 meters per second, meters over seconds. How far is the ball from the starting point when it stops moving? So we're interested in what happens when it stops moving. What does stop moving mean? Well, stop moving just means that the speed is equal to 0. The speed is v, so we just put v equal to 0. So we put 18 minus 4t equal to 0, and we calculate the time. We can then calculate the time when the ball stops moving. So we just solve this equation. So we get minus 4t equals minus 18, or t equals minus 18 over minus 4, plus 18 over plus 4, which is 4 2/4, or 4.5. And this is in seconds. Time is in seconds. So at t equals 4.5 seconds, the ball stops moving. So that's the time that it stops moving. But we don't want the time. We want to calculate how far is the ball. How far means calculate s. S is the distance. So we have the time. So the ball is going to be somewhere over here actually. But we want to find s. How far away is it from its starting position? Starting position is here. So we have the time, we just need to find s. Well, we just go back to this formula, connecting s and t. So we get s equals 18 times t, t is 4.5, minus 2 times 4.5 squared. S will be 40.5, and that's in meters, distance in meters. So when the ball is a distance of 40.5 meters from its starting point, its speed is 0. V equals 0. It stops. Actually, what has been happening is the ball started here and it moved to the right, and its speed kept on decreasing, and then eventually stops. But it doesn't stay stopped, it actually starts moving to the left. Show that the speed of the ball decreases at a constant rate while it is moving. Now, if we're talking about how the speed of the ball changes, we're talking about the acceleration. Acceleration, denoted by the letter A, is the rate of change of speed with respect to time. The change in the speed divided by the time taken, or dv dt. So we need to differentiate 18 minus 4t with respect to t to get the acceleration of the ball, and the acceleration tells us how the speed of the ball is changing. So we have to differentiate this function here. If we differentiate 18 with respect to t, we get 0. 18 is just a constant. It doesn't change when time changes. If we differentiate minus 4t with respect to t, we get the number in front of t, which is minus 4. So this is the acceleration. Notice that it does not depend on t. The units of acceleration are speed over time. The units of speed divided by the units of time, or meters per second divided by seconds. By the way, this is just an aside, but meters per second is like m over s, divided by seconds is equivalent to multiplying by 1 over s. So this is the same as meters over s by s is s squared. So the units are meters per second squared. Units of acceleration. This is constant. That's all you've got to indicate here, that the acceleration is constant. So that tells us that the speed decreases by a constant minus 4 meters per second each second. So the ball starts out with a certain speed, we weren't actually told to work out the speed of the ball, but as a bit extra, I'm going to just discuss the acceleration of this ball, or discuss how the speed is changing. So the question is complete. I just want to just do a little bit extra. We could get the speed of the ball at t equals 0. We could write it like this: v at 0. That means we just plug 0 in for t. That's 18 minus 4 times 0, or 18 minus 0 is 18 meters per second. That's the speed. So it starts out with a speed of 18 meters per second. This arrow here represents the speed. And the ball decreases to a speed of 0. But when we say the acceleration is minus 4, what we mean is the speed goes from 18 down to 0 at a rate of minus 4 meters per second each second. So in 1 second, the speed will drop to 14 meters per second. So the ball will be somewhere here with a speed of 14 meters per second. The ball will be somewhere here 1 second later. Another second later, the ball will be somewhere here with a speed of 10 meters per second. Yet another second later, the ball will be somewhere here with a speed of 6 meters per second. So that's the general idea. So each second of time leads to a decrease in the speed of 4. So the speed is decreasing by 4 meters per second each second. That's what meters per second squared means. It means meters per second per second.